Hi, today I want to talk about Ansys Maxwell 2D and 3D Graphical User Interface. First of all, I'll be using Ansys Electronic Desktop 2021 R1 version. This is what's inside Ansys Electronic Desktop. We got HSS, Q3D, Circuit, Emit, iSpec, Maxwell 2D and 3D, Simplorer, and Mechanical. Right now we're going to click Maxwell 2D. This is what inside Maxwell 2D. First of all, you have a menu bar, File, Edit, View, Project, Draw, Modeler, Maxwell 2D, Tools, Window, and Help. Firstly, I want to show you we have Maxwell PDF, where we can see all the guideline for Maxwell. So you just click on Maxwell Help and they will give you all the table of all the things that you need for Ansys Maxwell. Now we're going to close it, and we have modeler. We can change the unit, so for this time we are using millimeter. Click OK. And then this is the toolbars. We have desktop, view, draw, model, simulation, result, automation, and Minerva. Now I'm going to use the draw toolbar to create a rectangle or a square. So first of all, we just click on the 0, 0, and then here we have dx and dy. I want to make a 10 by 10 square, so I just change it 10, 10, and click enter. Now we have a 10 by 10 square. Firstly, I want to change the material for this square. You can do this by right click on the square and assign material, or from the properties manager window you can just change the material here and click edit. Same goes to here, assign material. For this one I want to use DFE-Tech. We can see the material properties from view or edit materials. Right now we are using it as the x component equals to with the value of 1, which means the x component is the north side of a magnet, and DFE-30 is a magnetic material, is a magnet material. So we click OK. First of all, I want to make a model for a magnet, so that's why I'm using DFE-30. Now what we're going to do is we create a region, and here is the region. Create region, just click it, and all percentage offset change to 100%. Now what we're going to do is right click and select mode, change it to edges, or you just can simply change to E. So you click all the edges, and what we're going to do is assign the boundary. By that you can just right click from the edges selected and click boundary. This is all the boundary that we have inside Maxwell 2D. Or you can just go to the project manager window, right click on boundaries, assign, and click balloon. For this demo I will be using balloon. Now what we're going to do is we assign the I will show you the excitation We have excitation if you want to assign one. We have current density and terminal magnet. You also can just click on the object and right click, assign excitation. Same goes to parameters and mesh operation. We have on selection and inside selection, clone mesh and surface approximation. Same goes to here. We can just right click parameters and assign all the parameters. Same goes to the mesh. Now what we're going to do is we want to create this. First of all, I want to show you all the solution type that we have inside Maxwell 2D, which is the solver. And for this demo, I'm using magnetostatic solver. And we also have eddy current, transient, electrostatic, AC conduction, and DC conduction. Click OK. Now we create a solution setup simply by right click the analysis and add solution setup. And this is all the tab that inside solver setup. We have general, convergence, experimentation, solver, and default. On the general, I want to change the maximum number of passes into 15 and then click OK. Before we analyze the model, what I'm going to show you is the validation. We just click on validation to see if it's good to simulate or not. If everything is in here is checked, so we're good to go. Now to analyze, we just go to setup, right click and analyze, or you can just click analyze all from the simulation tab. Now I will click analyze all and save the project first. We can see from the message manager and the progress bar here. From the message manager window, they will say the normal conventional simulation. So that means that our simulation is already simulated. Now to see the result of the post processing, we click on the object and then right click on field overlays, field. This is what we can plot on the object. We have A field, H field, B field, G field, energy field, others, and some markers. Now we see the flux line. Click done. We can see the x-axis is the north of the magnet, and we can see the flux line of the magnet. Now we also can see the B field. I forgot to click the object. B field, I need to click. And oh sorry, B. I'm going to show you the B vector. Field B vector. You can see from north to south. We can change the error scale to be smaller, and then I will show you the field, the H field magnitude. See, it's a simple way to simulate a magnet. So that's all from me. Thank you.